I'll take 25. First step, make sure the single number is over the other side, which it already is. That's not a guarantee tomorrow. Make sure the single number is over the other side. Next step, group your x's together and your y's together. So I'm going to rewrite this as x squared plus 8x. Get the x's together, get the y's together, and again, keep that single number off to the other side of the equal sign. Now you're going to complete the square. We haven't even completed anything yet. Now you're going to complete the square. Twice. Let's start with the x's. X squared plus 8x. What's my b? You have an a and a b value up here. What's the b value? 8. So the procedure is take half of it and square it. And you get a new number out. What's that new number? 16. So I have x squared plus 8x plus 16. Now I'm going to do the same thing for the y's. What's the b value for the y's now? -4. So take half of it and square it and let me know what that new number is. +4. Now you just left the left side is heavier than the right side. It's unbalanced. What did we just add to the left side? 16 and 4. So that has to get added to the right side to keep this bad boy balanced. Good? Now you got to factor. All right, and I showed you guys that were here yesterday a little shortcut so you didn't have to factor. This right here will become, what was half your b value? 4. So x plus 4 all squared plus, what was your b value up here for the y's? So y, half of it, -2 all squared, and then over here looks like we had 16. Now there's your circle equation we like to work with. That is how you transform it tomorrow. Now you can pull the center out. The center will be the opposite of what's inside here, -4, +2. And remember the radius is, this is the radius squared. So whatever number squared gives me 16, which is 4. I'm going to ask you to do that tomorrow. Okay, nothing different than this one or number 24. And I'll even throw this one out. First, I don't know, maybe not, but it's one of the multiple choice questions. Big Al tried to complete the square and made a mistake yesterday. You got to find what step he made the mistake in. Okay? All right? So that's the other question that involves completing the square tomorrow. All right? You got to find where he made the mistake tomorrow. Anything else from the homework that we want to cover right now? Okay, maybe it won't come up. Oh, there we go. Anything else? Yes, Grace. Which one? 17. Where'd it go? Okay, a center at -3, 6 passes through 0, 6. Okay. Goes through. Okay, well, the first part I can easily set up, the left side of this, because I know the center part, so that's not a big deal. The part I need to find, though, is what's this r squared value? Okay, 2 ways of doing this. This is a point on the circle. This is a point on the circle, an x and a y point on the circle. So I could take 0, plug it in for x, and I could take 6 and plug it in for y. Whatever I end up with there, that's the r squared value that I can plug back in. Good? Or I could use distance formula between the two, and you guys that were here yesterday, I showed you this is basically the distance formula. Okay, when you plug it in. Or in this case, you could count, right? -3, 6 to 0, 6 is something you can count, I believe. Okay, tomorrow, if I have a question like this, you're probably not going to be able to count. So be prepared to plug in a point on the circle into the equation you already set up to find what the r squared value is, so you can plug it back into the equation. Good, Grace? Others? Anything else? Yes, Emma? 30. You good? Okay, yeah, 30 is a little tough because of that too. Yeah, that's probably why. Yep. Other questions? Good talk. You done? Anything else? Okay. If you want to show me the homework that you weren't here for yesterday, that's fine. I'll write it down real quick just to get it out of the way, and then we have to get it going with these constructions and reviewing for what's on there tomorrow. All right? Yes. Maybe on the Regents, but we'll get there. I would never, and you're never going to see this, Meg. This number should always be let's be honest, this number should always be a perfect square. Okay? Especially if you're going to graph it. I don't know how you're going to graph the square root of 5. I don't know how you're going to go 2 point whatever. That's not fair. All right, something maybe, something like this, 32. Not on the quiz tomorrow, but I could expect this on the Regents, where this is a circle you could easily graph, and this is a line. Find out the 2 points of intersection. Okay? All right. Actually, while I'm walking around, I'll just I'll leave up the topics for tomorrow if you want to take a look at them. Okay, I'm not gonna write this stuff down. What did I just write down? Yep. Okay.
You got a big game on Saturday, huh?
What do you want me? You want me to announce that? Okay, everyone, in case you wanted to know, yes, I am coaching pre-kindergarten soccer. So imagine my mentality and my demeanor. Yes, coaching 4-year-old soccer.
Wait, is he coaching your sister? No. Oh, you might have to kill Saint as a ref.
Okay.
Cool. Way to ruin it.
So yes.
Wait, how did you even know that? That was my sister's practice.
Yes, we had our first practice on Tuesday, if anybody's wondering. Yeah, it was. Yeah, let me tell you, it's taking a lot for me to humble myself and get me down to the 4-year-old level, especially during practice on Tuesday. I had one of my players come up to me and ask me if he could go hug his mom. I was like, sure, go ahead, hug your mom. Yep. And the T-shirts they're wearing for their games are yellow, so we had to come up with a team name. And I thought maybe, Demolition or just something badass, right? The Bananas. Okay, so yep, fits my style. Fits my style perfectly, right? Yep. And I was a little devastated when I heard that the most important part is not the fundamentals or maybe winning the game, was make sure you got the schedule for orange slices and popsicles after, because that's the most important part. So, yeah, it should be a good season for me. Yep. Should be good. Make sure I keep my level down a little bit. All right. Yes. So we'll see how that goes. Yeah. Mm-hmm. We'll see how that goes. Okay. Before we I might as well just start right here for tomorrow. Have your packets, page 51 of your packets right now, page 51. I tried to put a spot in your packet where all the theorems you'll need for the proof are right there. Okay, so pages 50 and 51 cover all the theorems that you would possibly need for any proof that I give you tomorrow. All right, all right there. We have also done a couple proofs previous in your packet. I know what the proof is tomorrow. I strongly recommend you go back and look at those proofs we've already done. Okay, strongly recommend. And there are 3 practice proofs at the end of your packet in the review section. Okay, if you keep going past page 51 to page 52, you will start seeing the review questions. I have no idea if we're going to get to them or not. I'm not going to check them if you did them tomorrow, but I'm not assigning any homework tonight either. Okay, it's just practice for you guys. I'll be here after school if you want to go over anything. All right, I am a little nervous about the proof just because we haven't done too many of them in here. But I think if you look back at the ones we've done in the packet and the 3 practice ones in the review section, I think you should be okay. Anything you want me to go more in depth with? There will be 1 construction. I'm going to go over 4 of them with you today. 1 of them will be on there tomorrow. If you forget how to do a construction and want to review it, I put all the videos under the circle folder on Aspen. All right, what we're about to do. And yes, you are going to have to factor or use quadratic formula at some point tomorrow when you set up a whole times external question. All right. And then yes, a big dog circle question is from quiz 2, part A, B, C, D, E, and F. Find a floater, find an outside, find a tweener, find an inscribed. I left the 45 review questions up on Aspen from the last quiz, so they're still up there if you want to. And there's still some in your review portion too. Okay, there's still some in there. Anything you want to talk about? Because like I said, I highly doubt I'll get to maybe 1 proof, maybe today, depending on how long these 4 constructions go. Anything here we want to go over? You want me to go in a little bit more depth about? So I do get a little nervous going into tomorrow. Completing the square on there. What's up, Jasmine?
Is there any questions from the quiz number 1 and 2?
The only thing from review will be from quiz 2, which is all the angles, remember. How to find all the angles. Okay? Yes, Meg. How many? How does that benefit you? Oh, 10. Number 10 is the proof. There you go. Anything else? Everyone's got a compass. Everyone's got a compass ready to go. All right, first construction with circles. Okay, first one. I have this circle. I have point P. I want you to construct, not line up your straight edge and draw it. Construct a line that's tangent to the circle through P. Okay, that's what I need right now. All right, that's what we're going to show using your compass. Don't just line your straight up edge up and draw it through. It intersects once. No, we're going to definitely know it intersects once. Here's how. We're going to use a theorem that you're going to tell me about in a second. Draw the radius into P. Draw the radius into P. When we eventually construct our tangent line, what are you going to know about those two? They'll be perpendicular. I believe we've gone over numerous times this year how to do a perpendicular line through a point. So I need a line, ready? Here's your goal right now. I need a line going through P that's perpendicular to the radius. How do we do that? It's one we've done multiple times this year. It's got to go through P perpendicular to that radius. Any thoughts before we get before I start just chiming in here. Maggie. Yep, got to extend your radius through P because we're going to put our compass on point P and try to do what, ladies and gentlemen? We're going to make an arc that intersects in two spots. Yep. I always like to open up my compass a little wider just so I know where the intersection point's going to be. Sometimes when you keep the compass the same opening the whole time, it'll intersect on P, and that's no good. And then where do I go with the compass? Go to the both points of intersection on your extended radius. And you can do this above or below. It does not matter. Two more arcs. That'll intersect each other. And then you line up P with that point of intersection, and it will hopefully be tangent. So you're just doing extend the radius and draw a perpendicular line. I'm not going to show you any new constructions here today. And now we know that these two have to be, by our theorem, perpendicular. Anything from you guys there you want to ask? I don't want to go too fast. We're comfortable with that one. Next one, how do I get a square in here? Well, hold on. Let me just, on my diagram here, let me throw, okay, so this is really what I'm looking for here at the end, right? What do you know about the sides? Okay, hold on. And what are the sides in this? What do I call them now that they're in the circle? I don't want to call them sides. They're what now that they're inside the circle? They're chords. And we have a theorem that says if the chords are congruent, so are the arcs. So our job right now, how do I get 4 congruent arcs? How do I get 4 congruent arcs? Well, I can tell you how to get 2 congruent arcs right away. How do I get 2 congruent arcs? Draw a diameter. Go ahead, take your straight edge. Draw in a diameter anywhere. All right, now how do I make that into 4? Bisect the diameter. How? Yep. I'm going to take my compass, put it on one end point of the diameter, open up my compass, more than half the length. And we're going to make a decent size arc here. Go to the other end point. This is nothing new, hopefully, for us. Hopefully, when you line up your straight edge, it also goes through the center. Now you have right angles, which means if the central angles are congruent, so are the arcs. And now we can draw in the chords that make up our square. And there's your square. And okay, we're guaranteed now that the sides are equal. What do you know about the angles of a square? Okay, let's get more precise than they're all equal. They're all 90. Anybody want to tell me a theorem right now? How I know that this angle in particular right here is 90 degrees? How do I know this angle is going to definitely 90 other than it looks like it? A theorem going into tomorrow we should know. Meg, what's up? And it's drawn to a inscribed angle drawn to a semicircle. All right, have to be a right angle. All right. Anything else there on the square? Because now we're going to go two sides more. All right. How do I get a hexagon in this beast? Okay, put a point somewhere on your circle. Put a point somewhere on your circle. Measure the distance from the center to that point. Don't encourage. And now, you got that opening of your compass, right? That's the distance from the center to the point you put on your circle. Now, slide your compass over to that point. Don't change the opening of your compass. And we are going to start making arc marks that are that length all the way around. Shoot. And then along with your 5 arc marks and the point you originally created, you should have 6 arcs right now. And you're going to connect them with chords. Everyone good on the hexagon? Okay. Oh boy, how about equilateral triangle? I refuse to go on to the next slide. Or you guys can, that's fine. I just don't want to do the work again. We've already done the construction. It's done. Equilateral triangle construction's done. Anybody? It's the same as the hexagon. Except, what's up, Orion? You connect every other one. Nice job. Yep. Now we're going to connect every other one. Okay, so it's the same as the hexagon. So make a point on your circle. Make a point on your circle. Measure the distance from the center to that point, go all the way around with 5 arc marks, but now you want to connect every other one. So those are the 4. Okay, those are the 4. If you forget or want to review them, they're all on Aspen under your circle folder. One of these will be on there tomorrow on the quiz. Okay, one of them. You can try to guess and just study that one, or maybe just study the 4. It's up to you. Anything before we start, I want to get into at least one proof here before we end class. Anything you want to go over with the constructions? All right, I'll let the class majority pick the proof you want to do. So if you go to the back of your packet towards the end of the review questions, the last 3 are proofs, I believe. Yep. So you guys have a choice of 27, 26, or 25 as a class. They're all very different. It's not like one's tougher than the other. They're just all of them use different theorems, so which is good. So that's why you want to definitely try them out. Answers are in the back. All right, here we go. Let's start this voting process. How many for 25? Okay, looks like we're going to do 25. You got it. Again, please try out the rest of them, though. Please try out the rest. All right. Everything's written in for you already. You're welcome. OE, the only thing I really got to mark is OE is congruent to OF. All right, got to prove the triangles. 5 methods, as you know. 5 methods to do it. I'm just going to do this right away just to get this out of the way. AD congruent to itself. Great job, everybody. That doesn't impress people. All right, now can you bust out any circle facts? Can we bust out any circle facts here that would get another pair of sides or angles? I don't care. What's up, Connor? Name the chords that are congruent. DB congruent to DC, yes. All right, here's the theorem. Chords. What do I know about those 2 chords? That's why I told you OE and OF were chords equidistant from the center are congruent. Yep. All right, I need one more pair of something then. Hi, Orion. Nice job. That is true. AB congruent to AC, another circle theorem. What did Orion just use there? What are AB and AC? Tangents drawn to same point are congruent. And then we're done. So you guys that wanted this one, there you go. Side, side. I guess we can go on to another one. We may not finish it, but 26, 27. Next one, 20. How many 26s? 27s? Don't overlook 26 either. Okay, just throwing that out there, everyone. Do not overlook 26. Just throwing that out there. Oh boy, huh? All right, well, we got two chords that are parallel. That's really the only givens that we can mark. Okay, so we got parallel chords. All right, look at the proof statement. BE congruent to CE. If I'm proving segments, usually this year we had to prove what before we got to the segments? Triangles. Find two triangles. One triangle's got BE as a side. The other triangle's got CE. And they look like we could probably prove them congruent. BAE and CDE. All right, can we get them congruent? All right, let's just get the verts out of the way. Angle BEA congruent to CED. Vertical angles are congruent. All right, congratulations. Now you're going to have to bust out some circles. Got something for me, Teddy? Yeah, you do. What do you got? Why? Okay, you don't want to say BA and CD. You want to say the arcs are congruent. Because the theorem is if the chords are parallel, the arcs in between are congruent. All right? So we can write, not the chords yet, but we can write arc BA is congruent to arc CD. What did I give you, Teddy? What did I give you at first? Parallel. Parallel chords imply, what'd you write down? Congruent arcs. Now that can lead me to what? If the arcs are congruent, now the chords are congruent. BA congruent to CD. What would be my reason here? What do you have? What do you have? Congruent arcs imply congruent chords. Yep. All right. Anybody find anything else? Because I need one more pair of congruent somethings here. What's up, Maggie? I think you named them. You're right. Here you go. Ready? This angle right here and this angle right here. Because they're inscribed, drawn to the same arc. Okay? That's all we can do here for today. Like I said at the beginning, you're on your own for most of it. I'll be here after school doing anything you need.